Thank you very much, and good morning, everybody. My name is Matt Sanson, and I am the COO of the Virtual Forge. Thank you, everybody, for joining us today. I think it's going to be a great session. We're going to be talking today about leveraging data, technology, and advanced analytics in the logistics space. So we are going to be talking about supply chain, use cases for this kind of data, and how companies are using this to get better at what they do. So let's dive right in. But before we get into the main topic, just a quick word about myself and about the Virtual Forge and how we came to be speaking on this topic today. So the Virtual Forge is a data-driven software development company. What this means is we make customized solutions for our clients who are across a lot of different industries and across the world that are very specific to their business needs. If you know VF, this is probably not a surprise. That is the majority of the business that we do. However, what you might not know is that we actually also have a third-party logistics business. And not only do we have a third-party logistics business, but we have been operating that business for nearly 30 years. And that's where I come in, because as the COO, I have the opportunity to participate in both sides of our business. And one of my roles is to make sure that what we're doing on the technology side of the business gets translated and leveraged on the third-party logistics side of the business. And we do this so that we can run an efficient business. We do this so that we can find value for our clients in the third-party logistics space. And it's one of the things that makes the Virtual Forge unique and uniquely suited to be talking about this topic today. So I'm going to get into a couple of things that we have done for our clients and our history. And then I will talk about a couple of things that are going on in the industry more generally. In fact, I'm going to start with that. Usually the place to start. So let's talk about supply chain and logistics, just put it into context of today. And the first thing that I'll say about that is that just like everything else in the world, in the last 5 years, this has been pretty heavily impacted by COVID. So if you think back to 2020 or prior to 2020 versus now, it's fair to say that people are a lot more comfortable both purchasing things online, having things shipped to their homes, and generally using home delivery as a method of receiving the things that they need. So if you look at parcel carriers, which is one way to measure this, the major parcel carriers, so that's UPS, FedEx, USPS, and now Amazon, those major carriers delivered 21.7 billion parcels in the US in 2023. So that's just parcels in the US. The numbers are massive. Fair to say that they spiked during COVID, and they haven't relaxed from those levels. So we've been seeing a lot of volume that way. If you look at the other side of this, which is e-commerce, and how much people are ordering through online portals and typically would get those items delivered to them, that's way up as well, particularly as a percentage of the total retail sales in the US. So that figure in 2019 represented, or that figure meaning e-commerce, as a category represented 10.6% of all US sales in 2019. Okay, so by the end of 2023, that figure had grown to become 15.4% of all US retail sales. So that 15.4% represents $1.1 trillion. So that's big numbers. And if you look at that dollar figure, that's about a doubling from 570 billion to 1.1 trillion in the e-commerce sales over that time period. So we've got more e-commerce happening. We have more parcels being delivered to recipients, and what that means for the logistics and third-party logistics business is the volume's up, volume's way up, and with that comes additional competition. It comes additional players in the market, and with all of that competition, people have to find a way to compete. So how do you compete when there are a lot of players around striving for the same business? Well, in my experience and in our experience, one of the most effective ways to do that is to compete with technology. So what we're seeing is technology is enabling the supply chain, third-party logistics providers to perform better, to operate with a lot more transparency and information that they have ever had before, and to deliver for their customers. Customer expectations are incredibly high. You have some companies who have been really effective in having an effective supply chain and managing that. So Amazon is one of the big successful examples of that. And the expectations customers have developed for timing, for speed of service, and quality of service in working with companies like Amazon, having those customer experiences as a regular part of their lives has driven expectations for the entire marketplace. So now everybody who is involved in the logistics space is subject to a lot of those same customer expectations that were developed by, a couple of very successful companies upping the ante on how their supply chain works for individual customers. So stakes have been raised. All businesses need to now compete and make sure that they are able to fulfill those heightened expectations. And this can be really challenging, particularly for customers who are small, who are just getting started, or have complexity in their individual supply chain, whether that be, a complex manufacturing an assembly scenario, or if they have a cold chain product. These scenarios make it really difficult for people to jump in and compete at the level that they need to today with the other players in the market. So how do companies meet those expectations while also recognizing that not everybody has the resources of Amazon or a major multinational like that? So there are a variety of ways, some of which do involve technology. And one of them, which I would like to discuss first, is something called elastic logistics. So elastic logistics is a term that you might hear more and more these days. So the essence of this is giving you the ability to grow or shrink your logistics footprint on demand. So these types of processes would favor using automation over manual labor where possible. It would favor using rentals and contractors over employees. And in a lot of cases, it does involve third parties. And what you see with elastic logistics has a lot of parallels to what we saw in the IT market, in the technology market over the last couple of years, where companies needed the ability to dramatically ramp up or dramatically ramp down IT resources that underpin their applications and websites. So they would do this so that they can meet peak demand with an appropriate customer experience, but also when usage was low, not bear the burden of paying for that level of infrastructure when the numbers of users did not require it. So this on the IT side was done through the growth of cloud computing. So vendors like AWS, like Google Cloud Services, like Azure came into the mix and changed the model from something that in the past was very data center driven, a lot of owned equipment in individual industries, to something where this service was provided as a managed service for companies. And this did a number of different things for them on the IT side, but I think the biggest of which is it took what used to be a major capital expense and turned it into an ongoing operational expense. And with that took away some of the barriers to entry. So you no longer needed the same level of expertise, the same level of spend up front on servers and things like that, and no longer needed to maintain a max capacity, as an individual entity. The cloud providers are able to manage a lot of that complexity, spread some of that cost, and they can balance across a lot of customers with need for use of that equipment so that you're not paying for peak capacity at all times. So that's the IT side. You can think of elastic logistics as the third-party logistics corollary to that. So this allows a business who may have uneven demand patterns or a quickly growing product or just some uncertainty about what their level of fulfillment needs are going to be able to protect the customer experience, right? So we want to be able to ramp to that demand when it's there, but also not have to outfit a massive logistics capability in hopes that that is the ultimate scenario. So pay for what you use and ramp that according to current volume. So in both of these cases, two things are tremendously important. I would say first of which is when you're building a core capability like this into a vendor relationship, you need to be very sure about that vendor. So having trust of that vendor, having visibility to their capabilities and knowing how that relationship will operate, tremendously important. Not entirely a tech thing, but I think bears mentioning. And then the second thing is this trust and this model, whether it's IT or whether it's an elastic logistics operation, is enabled by data. So data is what allows intelligent scaling to take place. It's what allows visibility and monitoring to that process so that the client can be comfortable with how that operation is working for them. So this information and transparency is really the bedrock, the foundation for either of these service models. Lucky for us, what we're seeing in 3PL and logistics is that there's more data than there has ever been before. So information regarding usage patterns, the location of goods and services, um, data from scanning devices and warehouse management systems and ERPs is becoming more and more available for these types of processes and for advanced analytics programs. So using the data, machine learning, other statistical and analytical methods can be used to derive much more accurate predictions of things like future demand and other key performance indicators, and allows companies to get to an end-to-end supply chain performance management. Um, and that management of performance from end to end is enabled by end-to-end supply chain visibility. So let's talk about that for a minute. So end-to-end supply chain performance management might be a bit of a misnomer, um, because the end-to-end process for supply chain is extremely broad. This can be everything from the beginning sourcing of raw materials through various manufacturing, assembly, or otherwise scenarios to end delivery to the customer. So, getting your arms around the visibility into this process is usually not just one thing. There are a lot of different systems involved. There's a lot of different data involved, which has to be taken in combination to describe this. So in reality, the end-to-end visibility is a series of smaller efforts against different segments of the supply chain that, when combined, give you a better sense of the entire end-to-end process. So getting to where things like advanced analytics and machine learning can be used to make improvements to the supply chain to provide that visibility comes down to selecting individual use cases that make sense for your business that you're trying to measure, and then applying appropriate technology and process and people to those use cases to be able to build out um, this view of the supply chain from end to end. And the underlying technologies, the underlying data tends to come from a lot of different systems. And so these things are best approached individually. So I'm going to talk about a few examples of those. And I'd like to start with predictive analytics. So predictive analytics is a process that is used to build a model using historical information to better predict future events. So this oftentimes uses machine learning, and the approach requires a lot of high quality historical information that both describes the result that you are attempting to predict, and also a lot of related factors that likely have contributed to that historical result. And those are typically referred to as features. So a data scientist will create a machine learning model that uses all of that data, the historical data, to predict and discover patterns within that information and determine the relationship between those features and those results, such that when fed new features that are from current data that have not yet had the result, they can accurately predict the likelihood of a result. So demand is one of the major categories that people oftentimes look to predict in a supply chain scenario. The ultimate demand for the item can tell you a lot of other things about what needs to be in place to support that. So that is a common target. But some other areas that are frequently analyzed in this fashion are turnaround time, inventory accuracy, inventory stocking requirements, so kind of location, um, predictive maintenance events, so when equipment is likely to break down or have an issue, and back order risk. So using advanced analytics against these use cases, companies can take both internal data and external data to be able to better anticipate what's going to happen in the future. I will say one area that has been complicated over the last several years for predictive analytics in this industry is COVID. And as I mentioned before, this is the same driver for some of the growth that we've seen. But when you have an extraordinary event in the historical data like that is unlikely to be experienced in the same way in the future, that can make future predictions more difficult, because that extraordinary event will twist the numbers a little bit in a way that can make these predictions less accurate. So there are ways to deal with this, but for the most part, that involves using more recent data sets and fresher data to make those predictions. It reduces the size of the sample data available to solve this problem. But at the same time, companies are finding intelligent ways to work around it and to still achieve the ultimate goal of better predictions based on historical data. Now, a different area that's getting a lot of attention right now, probably no surprise to the audience, are large language models. So these are things like ChatGPT and from OpenAI and Gemini from Google. And these are pre-trained deep learning models that are trained on top of massive data sets. And these get used primarily for generative AI, which allows the model to produce original written text based on a text prompt from the user. So these models have found a ton of use cases recently, and I would say that they have greatly improved the accessibility of AI, because the method of interaction with the tool, with the prompts and response, is very natural. There's some natural language processing or NLP that makes the process of interacting with the model very fluid, even for non-technical people. And we're seeing this start to be applied in the logistics industry in places like voice picking. So a warehouse associate would be able to do things like check on order status, or locate a product, learn things about inventory values purely using their voice, which could involve natural language processing for that voice encoding and decoding, and then also a large language model for a human understandable response. And additionally, customer service groups for sure are seeing some value from these types of tools to be able to both take inbound tickets where the LLM can have a semantic understanding of what that message includes. These can reference internal company documents to be able to get an understanding of how the company would recommend responding, and then actually craft a draft response for the individual in a professional manner based on the output of the LLM. So those are a couple of the ways that LLMs are being used within the industry. And I want to just take a moment to talk about something that we've worked on quite a bit over the last several months, which is this concept of using a large language model against internal company information to be able to create a way to recall details that are important to an individual company with a very simple search and find process. So when I say internal company documents, I mean things like policies and procedures. This could be fulfillment histories, customer service tickets, customer SLAs, emails, e-learning modules, etc. So a large language model gives a powerful way to be able to reference what can be a massive amount of internal company information to pull out the piece that the individual is looking for. This can be used within the context of a supply chain or in an entire business. The essence is to give you the ability to ask and answer questions that will improve findability of information using an AI to draw out not only the answer from all of the content made available to it, but also the ability to summarize that in an effective way and to cite the location from which it made those determinations and found those documents. So the Virtual Forge has created a tool to do exactly this, something that we are very excited about, which gives an AI permissioned access to internal company files that a business deems it should have access to. And this could include text files, audio files, video files, BI dashboards, e-learning modules, and more. We're developing more targets for the tool all the time. And this is targeted at creating an internal company search interface, right? So it enables you to find whatever you need from your own internal documents across different media types, permission profiles, and even languages. So we know that these days at any large organization, finding things, particularly content, can be a challenge. And this is a way to address this with a technical solution that is proving to be very natural for people to use, and a great way to be able to search massive amounts of content and make better use of it. So if that's interesting to you, you can let us know after the session and we can tell you more about my Content Scout. Okay, so let's talk about a couple of practical examples where we at VF have been able to help our clients with these sort of supply chain challenges. And the first I want to talk about is an example in the medical device segment where we were able to use existing data to help optimize a supply chain process. This particular client had a field sales force with hundreds of team members out in the field whose primary responsibility was delivering product samples to healthcare practitioners. And our role was to ensure that the field sales force members were stocked with sufficient inventory to be able to do their jobs. And the process was originally done manually as a batch. So everyone would get their resupply. By and large, everybody would get the same amount, all at the same time on a monthly basis. There were some challenges, of course, with that method where some team members would have too much product or too little. And because the supply was coming only once a month, it needed to be shipped very quickly to certain team members, which incurred some additional shipping charges to get the item there from the carriers. And so the result of all of this was the process was pretty unreliable and expensive. And it forced the management team of this group to spend a lot of time dealing with this to balance things out and make sure at the end of the day, everybody got what they needed out of the process. So VF worked with our client to improve the availability of product and improve the product mix available to the salespeople. And we did this by automating the allocation and distribution functions of the process. So this was a technical solution that leveraged supply and demand signals from the field sales force and from the warehouse where the available inventory was stored, and used an algorithm to smartly generate resupplies for orders and also to determine the optimal ship timing. So we would monitor inventory levels both in our 3PL warehouse and for each individual rep out in the field so that we would understand what was available to them today and to make sure that we understood what the optimal stocking level for each of those parties would be. And then we would draw information from historical usage patterns down to the individual and the product line so that we could evaluate how much product was required for them to do their jobs and how those demand patterns would change over time. And using the information about current supply, likely future demand, we were able to create custom reorder points and order quantities and product mixes to be able to size the replenishment orders specifically to the individuals who required them. We were also able to tweak ship timing. So no more monthly shipments. We were able to see based on supply and draw against that supply when inventory was likely to hit this reorder point. And we could use this information to be able to trigger the order at such a time that the individual would not cross into a low inventory situation, but also because we were doing this in advance, we were able to use slow and inexpensive shipping methods to get the product there at the appropriate arrival time. The end of this particular use case was we were able to solve the supply problems in the field. So we were able to increase the happiness of the field sales force. We were able to reduce the time spent by managers on administering this process. And because of our ability to utilize cheaper shipping methods, yet still land the product just in time, we were able to save this client $1 million in carrier shipping fees in year one and all the following years using this method. So one example that we're pretty proud of, just using available information, applying some simple algorithms using supply and demand signals that were largely available to create a more efficient process and a better process for the recipients of the shipments. So let's talk about a machine learning use case that the Virtual Forge had some direct involvement in. And this is for our 3PL operation and is part of our reverse logistics operation. So on our reverse logistics team, we have a work process that relies heavily on something called a debit memo. And debit memo is like a requested return. And we receive this information and process it to determine who the customer is, the type of inventory they're trying to return, expiration dates, lot numbers, and details like that. The business challenge was that the debit memos that we would receive were all in PDF form, so not the ideal format for data extraction. Came in a variety of different forms and formats depending on who the customer was who was initiating the return, and created a lot of work for our data entry team, who had to extract all of the information contained in this forms, ensure that was correctly done, and then enter that into our returns management system. So a complex manual process that involved extracting data from an image, essentially, was a perfect opportunity to introduce some robotic process automation. So the specific type of process that we wanted to use to do this is something called optical character recognition, or OCR. And OCR has been around for a while. You may have heard of it, and nowadays gets embedded into things like scanners, or even the iPhone has some features that involve extracting text from pictures and making it available. So there are a lot of different ways to go about it. There are a lot of different companies that have OCR products. But for our particular case, our use case, we determined that Azure OCR had the correct features for what we needed. So we decided to build an OCR pipeline in Azure based on the Azure Document Intelligence features. And what this pipeline had to do was to receive PDF, which could be from various vendors and various formats, needed to ingest the data contained in that PDF, to output that information into a structured format, which was required by our returns processing system, and then to allow an operator the ability to perform some validation checks, sum totals and things like that, against the data that was produced. So components of that system, we used blob storage, which was used to store the PDF files, the images, the document intelligence component, which was the actual AI tool used to process the information, and then some Azure functions, which is event-driven code that can be run during the processes. So using these tools, we were able to create a fully functional robotic automation process, which took the documents from initial receipt through the processing and validation of the data that was contained inside them. We were able to successfully run this process with a high degree of accuracy for all of our major clients and document types. In doing this, we were able to achieve a greater than 50% savings in manual data entry time against this process. That was a great result for us. It also produced a great result for our client because these forms can be very large. And so previously, there was a bit of a bottleneck when a lot of data entry needed to happen to ingest a number of new debit memos. Now, with that process having more automation associated with it, we're able to process a greater number of documents in a faster amount of time. And there are also, in reduction of manual efforts, some data quality benefits to the process as well. So one example where we had a very specific use case, something that we needed to get done, we were able to apply machine learning to that use case to create value for our customers, most importantly, but also some internal value back to ourselves. I hope that was helpful to learn a bit about the use cases and the technologies that different companies are using to enable their third-party logistics operations. Just to close things out a little bit, I do want to mention that, just like most other IT-focused projects, the success or failure of these types of objectives generally has to do with the availability of well-managed, clean data to support the processes, right? So you can have a great use case, you can have a great algorithm to be able to try to perform some data science, but at the end of the day, if the information going into that environment is not what it needs to be, it cannot be a successful effort. So I know this is kind of the eating your vegetables part of data science. It is less fun, but the future that allows these types of processes to take work off organizations and to perform better by having these advanced methods available is also one that needs to ensure that the data is being reliably produced, that its meaning and purpose and attributes are understood by the business, so that when it does come time to perform these types of analyses, it's ready to go and it's not producing results that are unexpected or misleading for the business. So there's still, I think, a lot of behind the scenes work that needs to go in to make all of these things successful. And we at the Virtual Forge have a lot of experience with doing this, and also have the scars to prove that we haven't always done it perfectly in the past. This can become complex with a lot of different systems and formats and expectations, but the dream of having end-to-end supply chain performance, as I said before, has to start with the foundation of data excellence from end to end as well.